I would like to welcome you all in the lecture series of power electronics. In this video, I'm going to discuss the operation of type B chopper. You know that type B chopper is also known as class B chopper. So we'll understand what do you mean by type B chopper definition. Okay, definition and meaning. Okay, definition and meaning. Later, we'll discuss the circuit diagram, working, and the further operation. Okay, yeah. So first we'll understand the meaning of type B chopper. So it is basically a type of step-up chopper. You know the meaning of step-up chopper. The average output voltage will always greater than the input voltage. V naught is always greater than V in. Okay, so that's a like a operation of step-up chopper. Similarly, it will perform the second quadrant operation. Second quadrant operation. Also, the output voltage, if I talk about the output voltage will be always positive, where the output current, you can see the output current, that will be negative. Why? Because it's operating in second quadrant. What is a major application? What is a major application? So it is mainly used for forward braking application, forward braking. Forward braking. Okay, in especially for electric vehicle, you can go for this type of converter, which is operating in the forward braking mode. Hope it is clear. Now we'll discuss the working. Okay, how does it work? So moving on to the operation. Yes. So let me talk about the working. First, let us consider how does it work. So we require the need circuit diagram. Okay. Circuit diagram is mandatory to explain the working. So first you can note down there is a supply. Okay, we require a DC supply, correct? No, battery or a DC supply. Then it is followed by a diode which is kept in the reverse direction. Then you can draw the switch. Okay. Fine. Later, you can draw the load. Load is basically RLE load because it's a motor load, right? RLE load. RLE. This is chopper, right? Switch. So we can mark like a Vs. This can be written as Vs. And the voltage across the load is V naught, correct? No? V naught. Positive with respect to negative. So we have I naught. Now, in the first case 1, the switch is on because this is a converter, chopper. It mainly works based on the switching action of like a power switch, right? On and off. Basically, within a fraction of second, millisecond or microsecond, the switch will be on and off continuously. First, we will consider the condition such a way that switch is on. Switch is on means you can mark in this fashion. Okay, this is on. Switch is on. Correct. Now, what you can do is you complete the path R L E. Correct, no? All right. Yeah. R L E. Switch is on. We got a closed path. Now, please tell me, what about the condition of diode? So diode is getting reverse biased. Why? Because positive comes over here, negative comes over here. So it will act as a reverse biased and keep open circuit. When it comes to the another loop, first loop, no conduction. If I talk about the second loop, you can see the E, right? This is actually called the EMF. Okay. Because it's a motor load, there is a back EMF, back EMF. Back EMF, or you can call it as a counter EMF, which will be produced due to the Faraday's laws of electromagnetic induction. So that those electromagnetics and all I'm not explaining, but because of this back EMF, we can say it will act as a source. So there will be like a current flow in this direction. Current flow will be taking place in this direction. Correct? Now, arrow also you can see there is a movement of current. So in this regard, what is going to happen? Inductor is getting energized. Inductor L is energized. Inductor L is getting energized. So of course, there will be a stored energy. Energy is getting stored. Okay, energy will be stored. Also, the peculiarities, the direction of load current is in this fashion, I naught. But what about the inductor current? Inductor current will be in the opposite direction. So we can write like I naught is equal to minus IL. In this particular fashion, you can write. Why? Because both the current direction is opposite. This is what exactly happening when the switch is on. Hope the concept is clear, I guess. Now, moving on to the second case number 2. What will happen when the switch is off? Switch is off. Okay. So here already inductor is getting charged, right? So now what you can do is during the off condition of the switch. Okay. Switch on and off will be controlled by the PWM, pulse width modulation techniques, right? So switch is off. I can mark in this particular direction, in the particular manner. So we'll note down RLE, RLE, correct? Yes. Here the inductor polarity will be plus negative minus, right? But where here the inductor polarity I can draw in the different manner, like it is getting released, no? So minus plus I can draw in this fashion. So how about the direction of current? Of course, this is I naught. What about the inductor current? It will be in this direction, correct? No? Yes. Okay. Here, what are the changes which you can observe? Inductor will be de-energized. Okay. Like a de-energization. De-energization of inductor. Inductor will be energy will be released. Okay. So what will happen at the output? So if I talk about like the output voltage will be the sum of inductor voltage plus like a EMF. Okay. So the output voltage that will be always greater than input voltage. So we can this is VL. So output voltage will be the sum of VL and E. So that is what exactly happening here. Now we'll see the waveforms. How we can draw the waveforms. Okay. It's pretty clear that the switching action will be done with the help of PWM. So switching pulse will be like which will be having like a on period as well as off period, right? So we can control the on period and off period, right? So based upon that, the switch on and off period will be different. So during so whenever the switch is on, what we observed is output voltage will be zero only, correct? No, because it become a closed circuit, a short circuit. So output will be dead short in the sense zero. When switch is off, what is going to happen? The inductor energy, whatever the energy which is stored in the inductor, that is getting released. Okay. So in addition to that, the output voltage will be the sum of the inductor voltage and the input voltage. That means output voltage will be always greater than input voltage. So the output voltage that will come across the load in this particular fashion. So this is what exactly happening during whenever the switch is off. The cycle will be repeated. Okay, that you can very clearly observe. What about the changes in the current? If I talk about the current, see at the beginning, as soon as the switch is closed, when the switch is on, so inductor current will be getting increased. Since it is continuous conduction mode, inductor current never reaches to zero. That is what I have drawn. In spite of putting in zero, I have drawn here because we are working this particular converter in the continuous conduction mode. So whenever the switch is off, whatever the energy which is stored in the inductor that is getting released, thereby inductor current is getting reduced. Like this, you can draw, correct? So this is what exactly happening whenever switch is on and off. This waveform is very essential to analyze the circuit. Okay, basically this converter will act as a step-up converter or a chopper, step-up chopper. So another important thing, the quadrant diagram. So I already told you that this is actually operating in the second quadrant, right? So here we can see the in the current direction, because the I naught will be equal to minus IL, correct? No? So inductor current and output current direction is entirely different. That is what the current is in the output current is negative, correct? Because inductor value of inductor current that is getting decreased, right, as soon as the switch is off. So another important thing is output voltage remain positive only. Okay, these are the minor changes which you can observe in the circuit diagram. I think the concept is clear to everybody. Yeah. So in the coming session, I'm going to talk about the class C chopper, which is the combination of class A and the class B. So you may some people will call type A also, type A and type B. That's also correct. Let me know if you have any queries. I'm welcome your queries. Happy learning. Have a great day. Please go through the session. Thank you.